y also move around, so it doesn't help you so much get a handle of what it could be. Okay, what's the other possibility that's centers?
Yeah.
Okay. So, let's get that. So that's R1, the radius of this one. Make the radius of this one R2. So the power of P with respect to the first circle is what? P01 squared minus R1 squared. And with the other one is what?
P02 squared.
P02 squared minus R2 squared. Okay. Well, that's something. Let's just draw. You've got P01 squared. Let's draw in P02 squared. So there is something here, I'll tell you that much. But we need to do something. So we've got PO squared minus the other PO squared. And we've got the line between the center of the two circles.
It's a right angle. No. What?
So what's a right angle?
The triangle P01, O2 is a right angle triangle. No.
This angle P01, O2.
Yes.
That's not a right angle. But when you mention right angle, there is something.
I meant right angle triangle. That
Where?
The P01, O2, that triangle.
P01, O2
Yes.
is a right angle triangle.
No.
I don't think it is. Unfortunately. Okay, but what if we took P and we dropped a right angle onto that line connecting the two? And let's call this point, I don't know, T. Then what can we do? Yeah.
You can use the program.
Yes. Okay, where?
I don't know.
Well, we have PO1 squared, which is that one, and we've got the right angle triangle there.
You can write two equations for PT and then equate them with Pythagoras. So P01 squared minus T01 squared equals PT squared, which is also equal to P02 squared minus O2T squared.
Cool. Yeah, that's basically what we're going to do now. So what we're going to do is in this formula where we see PO1 squared, we're going to do PT squared plus T01 squared minus R1 squared. And on this side, PO2 is PT squared plus TO2 squared minus R2 squared. Okay, why is that good? What happens?
PT squared cancels.
So PT squares cancels out. Yeah. Yeah. Cool. And what do you notice about this equation there? The last equation with respect to P? There's no P. So this equation doesn't depend on P. It depends on T, which kind of depends on P, but it doesn't have any P in it itself. So if you find one point T on here, which satisfies this equation, then if you take any point P and you drop it and you get T, then that's then that point P will also satisfy it. Okay, that is confusing, right? The way I said it right now was confusing? Yes? Yes? Good. Not really. But anyway, okay, so what I'm saying is if I change P, if I choose a different point P, let's say over there or over there, and I drop it and I get the same point T, the point T is the same, so this equation will still be satisfied. So I can take any point here and drop, and that point P will still satisfy this equation. So what does the set of points look like?
A straight line.
It's a line perpendicular through this point T. Cool. That's cool, right? Nod. Just nod. Good. Okay. So this is called, this line is called the radical axis. So if you have any two circles, the radical axis is the set of points that have the same power with respect to both circles. Cool. Now, so all you basically need to know in order to draw the radical axis is you need to know where this point T is. Now it's somewhere on this line between O1 and O2. Can we somehow calculate where it is? Yeah, so basically we'll need to use this equation. So you take the stuff with T over to the one side, take all the R's over to the other side, and get TO1 squared minus TO2 squared, R1 squared minus R2 squared. And when you have a square minus another square, what do?
Factorize.
Yeah, factorize difference of squares. So TO1 minus TO2 times TO1 plus TO2. What's TO1 plus TO2?
It's 2TO1. Oh, TO1 plus TO2.
Yeah. Yeah, so that's just O1, O2. So you actually have a linear equation, not a quadratic that you need to solve. So cool. And so TO1 plus TO2 is O1, O2. So you can substitute O1, O2 for this bracket. And for the other one, you can just say TO2 is O1, O2 minus TO1. So you'll only be left with TO1. You can just solve the linear equation for TO1, find out what the length is, and then you can dance and jump around for joy and stuff. And then you can laugh because my jokes are funny, okay? Okay. So we know that the radical axis is a line. Keep that in mind. Now, what happens if you have a circle, surprise, okay, you've got one circle. Oh, that is a perfect, almost perfect circle. Okay, and you've got another circle. Okay, what is the radical axis of those two circles? Okay, I've got a hand at the back. Okay, I've got so many hands. Okay, let's start that guy at the back first.
The line between the two intersections.
Okay, so you're saying the line between there. Why? Gut feeling. Okay, so you're in the third round of the demo, and you're solving the question. You're like, it's this. But you have to write down a proof, and you're just like, gut feeling. It's not gonna fly. Okay, how about you? Okay, anyone that does not have a gut feeling?
Just makes sense.
What's special about these 2 points? In terms of power of a point. Yeah, what he said. These both have power of a point 0. So this point has power 0 with respect to this circle, 0 with respect to that circle. This one also has the same. And because we know that the radical axis is a line, it has to go through these 2 points, so it's that line. Cool. Okay, so now should I like really blow your minds? Yes. No? Yes. Okay, what if I draw another circle? Good enough. Okay, so what's the radical axis of these 2 circles? So, yeah, between there and